Okay. So this is lesson 2.3. It's 2 pages, and we're just going to talk about the idea of a logarithm. So exponential functions are of such importance to mathematics that their inverse function, the reverse, remember, are important themselves. These functions are known as logarithms, and we're going to talk about them in this lesson. So remember that if we want to find the inverse of a function and we're given a table of values, how do we find the inverse of it? What do we do to the x and the y ordered pairs? You can look in your journal. How do I find the inverse? What do I do with the x and the y? Switch spots. Okay? So our first question says, is this function 1 to 1? Is this function 1 to 1? I think I gave you those, yes. Is it 1 to 1? How do you know if it is? You can't just say yes. You got to justify it, right? How do you know if this is 1 to 1? How do you know if it's 1 to 1?
It passes the vertical like that.
Yes. We know that a function is 1 to 1 if it passes the vertical and the horizontal line test. So is this function 1 to 1? Yes or no?
Yes.
Yes, because it passes the vertical and the horizontal line test. So let's write that. Yes, because it passes both the vertical and the horizontal line test. And I'm going to just draw a quick sketch so you remember what those are. So yes, because it passes both vertical line test and horizontal line test. So remember that the vertical line test just goes like this. Vertical lines, it only touches the function once. Horizontal line test, same thing, only touches the function once. So this passes both, and if it does, that means it's 1 to 1. We know that if a function is 1 to 1, it means that its inverse is also a function. So it says, based on your answers from part A, what must be true about the inverse of the function? Well, the inverse is also a function. So we have to create a table of values below for the inverse of f of x equals 2 to the power of x. So remember, if we want to create an inverse, and we're already given a table of values of the function, all you do is trade spots with the x and the y. So x is now 1/8 and y is -3. I look at this ordered pair, x is now 1/4 and y is -2. X is now 1/2 and y is -1. X is now 1 and y is 0. X is, X is 2 and y is 1. X is 4 and y is 2. X is 8 and y is 3. All I did was took each ordered pair and changed the x and the y. That's it. Okay? So now I want to graph it. So let's see, when x is 1/8, that's like almost right exactly on the y-axis. I'm going to go down to -3. Get as close to the y-axis as I possibly can. Well, when x is 1/4, I'm at -2. That's still pretty close to the y-axis. When x is 1/2, I'm at -1. When x is 1, my output is 0. When x is 2, my output is 1. And when x is 4, my output is 2. And when x is 8, my output is 3. This is the inverse. This is the function. I don't want to use y, I want to use f of x. This is f of -1 of x. This is the inverse of my function. Okay. It says notice, as always, the graphs of f of x and f inverse of x are symmetric. And we talked about this when we did inverses. They're symmetric across the line y equals 1. Okay. What would be the first step to find an equation for this inverse algebraically? Well, we started with the equation y equals 2 to the power of x. When I want to find the inverse, what is the first thing that I do algebraically? Okay. I switch the x and y and then solve for y. Switch places with the x and y and solve for y. So let's see, what would that look like? That would look like x equals 2 to the power of y. And you have y, what you're trying to solve for, in the exponent position. And you don't know how to do that. You don't know how to get rid of that, which is why logarithms were created. Defining the logarithmic function. The function y equals log of b of x is the name we give to the inverse y equals b of x. For example, y equals log base 2 of x is the inverse of y equals 2 to the power of x. Based on exercise 1D, we can write an equivalent exponential equation for each logarithmic equation as follows. We already practiced this. This is what that whole worksheet was about, right? This is my base. This is my solution. This is my power. So the log of my base of x equals my power, which is exactly what they have here. Just I put like in reverse order instead of starting it with y. It's the same thing, okay? So we already practiced that. I thought it'd be easier to practice looking at it before we started it. So based on this, we see that logarithm gives its output, the y value, the exponent we must raise to b in order to produce its input value. Okay, so let's keep on going. So now we're going to evaluate logarithms. We already did this on this worksheet. Remember, this is saying 2 to what power equals 8? 2 to what power equals 8? 2 to the third power. This is saying, I'll even write it out, 4 to what power equals 16? Yeah, I said that when I gave it to you because I used a light blue pen. So you're going to have to look up at the board. Well, here, you can just have this. It's light blue, though. I'm sorry, it didn't pick it up when it colored. So what power is that? 4 to what power? 4 to the second power, yeah. 5 to what power is 625? To the fourth. 10 to what power equals 100,000? How do we feel about that? Good? Okay. Are you using the calculator form? Easy, right? Okay. 6 to what power is 1 over 36? -2. Very good. 2 to what power is 1/16? -4. Does that make sense? Hayden, does that make sense? Okay. Whenever I see a fraction, I say to myself, like, I just look at this as 2 to what power equals 16, and then I make it negative. That's how I think about that. Okay. Let's look at this next one. 5 to what power is the square root of 5? We know that the square root is the same thing as the power of 1/2. Why is that? Because this is the power and this is the root. Okay. This last one says 3 to what power equals the 5th root of 9? Yes. What is it? 0.4, which is the same thing as 2/5. 3 squared is 9. 3 squared is 9. And the root is 5. Let me say this again. 3 squared is 9. That's my power. And the root is the 5th root in the denominator. Okay? It's critically important to understand that logarithms give exponents as their outputs. That's like so important. We just need to do this. Logarithms give exponents as their outputs. We will be working for multiple lessons on logarithms and a basic understanding of their inputs and outputs. If the function y equals log base 2 of x plus 8 plus 9 was graphed in the coordinate plane, which of the following would be the y-intercept? Well, let's just talk about the y-intercept because that's crazy. Let's see. What do I know about the y-intercept? Well, I know that the y-intercept happens when x is, say it, 0. That is huge, right? That is like a key idea from Math 1. The y-intercept happens when x is 0. So why don't I just look at this crazy equation and let x equal 0? So I have log base 2 of 0 plus 8. Well, that's just 8 plus 9. Okay, so this part, this log base 2 of 8, that's saying 2 to what power equals 8? That's what that's saying. 2 to what power is 8? 3. So this whole parenthesis, this whole like, trying to look for another color. This piece right here is the same thing as saying 3 plus 9. And what is 3 plus 9? 12. Okay. Here's another question that always stumps you guys, and I don't know why. Between what two consecutive integers must log base 3 of 40 lie? So that's all right. 3 to what power? 3 to what power? And then the number 40, right? Well, 3 squared is 9. 3 cubed is 27. 3 to the 4th is 81. Whoops, sorry. That should have been a 4 right there. 3 to the 4th is 81. So 27 is less than 40 is less than 81. So what are the two integers? Your two exponents, 3 and 4, which is answer choice 4. Okay. Calculator use. So we talked about the common log already, but we'll talk about it again. So you have the log button on your calculator. It's right here. Just says log. Use that when you know that you're operating with base of 10, log base 10. Otherwise, you have to press the math button and go all the way down to where it says capital A log base. Got it? Okay. So let's just do these really quick. This is saying 10 to what power equals 100? 2. This is saying 10 to what power equals 1 over 1,000? -3. Max, you're good at this. This is saying 10 to what power equals the square root of 10? Is that it? Is that both pages already?